I'm Jim Pomerantz, Professor of Psychology and Director of Scientia, and this is our opening lecture of the academic year, the first in a series that we hope and expect you will find exciting, perhaps a bit unsettling, and we hope difficult to forget. Our theme this year is conflict, violence, and war. We have the perfect speaker to get us started today. Don't misinterpret. In Joan Strassmann, who's a leading biologist and well-known and highly regarded member of the Rice faculty, and I'll be introducing Joan in just a moment. But first, let me set the backdrop. As many of you know, Scientia is an institute for the history of science and culture that was founded in 1981 at Rice by the mathematician and historian of science Solomon Bachner. Scientia is a creature of the Rice faculty, but its goal is to present speakers and programs for the widest possible audience, bringing together not only Rice faculty, but students, alumni, and staff to join in the conversation. We also aim to attract others from outside the hedges, ranging from our colleagues across the street in the Texas Medical Center and other nearby institutions, to others working in Houston who share our interests, and to our neighbors whom we're always pleased to see here on campus. It's a pleasure to introduce key members of the Rice Academic Administration who take time out of their hectic schedules to be with us and to see what Rice faculty are up to in their research and in their scholarship. And I am pleased more than I can say to welcome Rice's new president, David Lebrun, who's with us this afternoon and is taking in his first Scientia lecture. Joan, you're under no pressure at all today. It's just another lecture. David, the Rice faculty are delighted that you've joined us as our president and as our colleague. You've sent a clear message across this campus in your first 3 months, a message that emphasizes the centrality of scholarship and intellectual focus that must underlie all activities undertaken on this campus. This is a message we're eager to hear and one that we are looking forward to working with you closely on in the coming years. I'm also happy to note that our usual crowd of decanal regulars are with us, including Deans Burris, Matthews, and McIntyre, as well as other former deans. Jim Kinsey's here, King Walters. I'm a recycled dean myself. And other members of the administration. Scientia's role in Rice's affairs has expanded in the last year with Provost Gene Levy assigning to Scientia the primary oversight of the DeLange Conference, which is Rice's premier conference series. And I'm happy to announce that the 5th DeLange Conference on the topic of frontiers of medicine will be held on campus this spring break from March 7th through 9th. More information about that conference is down here on the tables. Ellen Butler has provided it, and we'd be happy to tell you more about it. I should note that the DeLange Conference is made possible through a generous gift to Rice University from Hank and Damaris Hudspeth, who are seated over here in the third row. Hank and Damaris attend most Rice University events, I'm pleased to say. And if you ever attend a Scientia lecture and Hank isn't in the audience, it means there's been a disturbance in the force. So Hank and Damaris, thank you for your continued support. And let me ask all of you to keep on the lookout for an announcement in the forthcoming issue of the Rice News calling for proposals for the 6th DeLange Conference to be held on campus probably sometime in 2007 or 2008. And I'd urge you to get in touch with Steve Kroll in the philosophy department for more about that. The success of Scientia is the result of the efforts of many people, especially the growing list of speakers, including Joan Strassmann today, who share with us their ideas and their time. Scientia's successes are also the result of the work of many people, the members of the Rice faculty who helped to identify the themes for Scientia for the coming year, to identify our lecturers, and to orchestrate the entire program so it coheres. Speaking personally, I can confirm that much of the success of Scientia is also due to the hard work of our extraordinarily capable executive assistant, Ellen Butler, who is usually out of the room when I mention her name, busy doing other things that make this program work so successfully. She's the one that handles all of the arrangements. For any of you who've ever tried to put together something of this magnitude, you know it's a lot of work and not much fun. So thank you very much, Ellen. I'd like to also thank our IT staff, led this year by Tom Lydell, who makes sure that all the microphones and the AV work. So. I better hurry up. Thanks, Bob. So our theme this year is conflict, violence, and war, and as is true every year, this theme is developed by a committee of faculty led this year by Professor David Queller of the Department of Ecology and Evolutionary Biology. You can read more about the theme on the program cards and see who the speakers who are coming up. But let me just say briefly what it is that we're going for this year by reading what we affectionately call the program blurb, which simply says, the desire for peace and tranquility may run deep in the human spirit, but conflict, violence, and war have been nearly ubiquitous hallmarks of our past. This year's series will examine the nature and origins of violent conflict, not only in modern-day warfare and throughout human history, but in its evolutionary roots within other animal species. By examining a spectrum extending from the appearance of violence in images to the occurrence of competition versus cooperation in experimental gaming and bargaining experiments, we will examine these causes and possible purposes of violent behavior, as well as what might be done to contain violence in the future. Following Joan's talk today, we have a whole series of speakers lined up. Just briefly, we'll hear next from Marty Weiner of the History Department on October 26th, who will be talking, obviously, about the history of violence. David Cook from Religious Studies will speak to us on November 16th about jihad and its relationship to violence. And then rounding out our fall program, we'll hear in December 7th from Rick Stoll of Political Science, who will be talking about international conflict and whether it's true that nice states finish last. Then we have a program for the spring that is still in development, but it includes Kirsten Oster in English, Rick Wilson, also of Political Science, and Dave Schneider in Psychology. We're still in the process of lining up our Bachner lecturer. That's the outside speaker who's the premier, gives the sort of centerpiece talk of the year. Finally, before I introduce Joan, let me just say we're following the familiar format for those of you who have been here before. Joan will talk on time, she assures me, for the standard faculty unit of time, 50 or 55 minutes as soon as I stop. And that will be followed by 15 minutes of Q&A, and remember to ask your questions in what we call question format. And that will be followed finally by a wine and cheese reception directly outside the room. So now for the reason why we're gathered here today, to hear from Joan E. Strassmann of Ecology and Evolutionary Biology. Joan is well known to many in the Scientia crowd, not only for her very interesting and highly regarded research program, but by also being one of the faithful who hardly ever misses a Scientia lecture. So it'll be a treat to get to hear from Joan this time. Joan's not only a professor in the Ecology and Evolutionary Biology department, she's also the chair. So as many people in this room can testify, being a department chair is often a thankless task that leaves little free time for other elective activities like giving public lectures at Scientia. So Joan, I'm not going to thank you for being department chair. That's thankless, remember? But I will thank you for taking the time out to speak to us. Joan received her high school diploma in 1970. I don't usually mention such early milestones in the career of scholars, but in Joan's case it's interesting because her diploma came from the International School of Geneva, Switzerland. She then went on to get her B.S. in zoology from the University of Michigan, something that she and I share in common, where she received the Hopwood Award for undergraduate fiction in 1973. Then she went on for her PhD from UT Austin and did a one-year postdoc at Austin before coming to Rice as an assistant professor, and she has worked her way quickly and impressively up through the ranks, reaching full professor in 1993. Her list of honors, awards, and publications is one that any of us would envy. Her awards and fellowships alone number more than 25, her most recent of them being a real head-turner, a 5-year, $5 million grant from the National Science Foundation on the evolution of social biological systems. Her journal publications appear in the most respected outlets, and they number over 100. She currently sits on the editorial board of Insectus Socio, which I'm sure most of you read, and is on other advisory committees and societies, serves as a reviewer for what appears to be wheelbarrow loads of grant proposals going into the NSF. She's an elected fellow of the Animal Behavior Society and was president of the North American section of the International Union for the Study of Social Insects. Closer to home, she's been recognized as the outstanding associate at Weiss College and also is the winner of the Julia Miles Chance Prize for Excellence in Teaching. Perhaps the most gratifying of all was the announcement earlier this year, which I'm sure most people in this room were pleased to hear as well, of Joan's being named a Guggenheim Fellow. So, as always, let me ask you to turn off your pagers, your cell phones, and anything else that is capable of making annoying sounds, and to tune in to Joan Strassmann, whose title is Conflict and Violence in Animals. Joan Strassmann.
It's a great pleasure to be here, and it's true, I have been to a lot of Scientia talks, and I really try hard to stay awake. Wasn't so critical, though, when we were in the Kyle Morrow room where you couldn't really see the people in the back. Here I can see you, so just keep that in mind, given my topic. Violence is one of those fascinating and scary topics. A leader can kill thousands of babies by not funding vaccine programs, but it doesn't somehow bother us very much. But should he scream angrily even once, and then he'll be viewed as dangerous and unpredictable and lose popular support? Why? We can be mortally hurt in many ways, but it is the violent ones that we fear the most. Violent death comes most often to Americans in our beloved automobiles, killing, for example, in 2001, 42,493 people, according to the National Vital Statistics reports. But somehow that isn't our greatest fear from 2001. Our greatest fear is violence from the purposeful hand of another human being. Why? Well, death is the most extreme result of violence, but its lesser outcomes also terrify, and we change our behavior, both personally and as a society, in all kinds of ways to avoid violence. But all this is really not my topic. It's topic for later on in this series, and you should certainly come to the later topics. What I'd like to ask is, can we learn anything about violence by studying other animals? Can we see how animals deal with violence? Do they even face violence? There was a time at which it was viewed that animals could just work everything out and not really have to get to the point of actual violence. I've been here at Rice for 25 years studying conflict and cooperation in wasps, in stingless bees, and most recently in social amoebae. What I've taught is animal behavior, again for 25 years, and I've eaten lunch with undergraduates at Weiss College. Not quite for 25 years. So this is the experience that I bring to bear. Should make one thing clear right from the start, and that is that when I say violence, what I mean is lion on lion, human on human, social amoeba on social amoeba, not a lion killing a gazelle. That may look terrifying, it may look bad, but at the end of the day, it's just eating, just like a caterpillar eating a leaf. Now, certainly both gazelle and leaf will evolve anti-predator strategies, but this is a fundamentally different phenomenon, at least for an evolutionary biologist. So I won't be talking about that. Well, do animals fight? I'm sure you all think that, yes, they do. Here we have a bighorn sheep who's got all kinds of adaptations for fighting. These kangaroos can use their feet. Even animals that are hard to recognize as animals will fight. They have stinging. They can sting with those tentacles, and this is speeded up. But this is a battle for territory between two genetically distinct clones, and here they are fighting. Now, I worried a little bit about showing all these videos with our new president who's a lawyer. I thought thought maybe he'll just see this whole talk as one huge copyright violation. So I'll just start out right off by telling you that these videos mostly come from David Attenborough's Trials of Life, which I highly recommend. Zebras, another nice herbivore. Males fight like crazy for their harems of females to whom they want to gain sexual access. So why do animals fight? Why do they do this? Why do they attack each other? Here we have some Midas cichlids. Again, they're fighting for territory. These two are equal in size. They're shoving each other with lip to lip. They don't really have much in the way of teeth, and the winner will keep the territory. Why can't they be more like these Grant's gazelles here? They're not doing ballet. They're actually sizing each other up, and this is a very clear display. They walk around each other, they head duck, they're displaying. And one might say that often in the animal world, escalated conflict of the sort I showed you before is simply the result of the failure to resolve who's likely to win from displays. And displays nearly always precede escalated conflict. You can view it as a way of communicating. Well, what are they communicating? They're communicating their ability to escalate into violence and win, and their motivation to do so. A really small but crazy guy can often overcome a bigger male who is just likely to run off. So here these Grant's gazelles, they have horns. They could fight with them. They could shove each other and possibly gouge each other, although they're bent back. They've evolved that way to avoid that. I'm an evolutionary biologist, so we get our reasons for why the animals do what they do from one thing, and that's evolutionary biology. An individual will not escalate because it can pass on more genes to the next generation by leaving, if it figures it's going to lose, than by having an escalated fight. And that's how evolution works. So when we look for an advantage to resolving a conflict without escalation, where we're looking is in individual motivation for restraint. If we looked anywhere else, anytime a new gene that caused you to escalate instead cropped up would be selected for. So over evolutionary time, it's a safe bet that if there's a more optimal strategy, a gene that predisposed an individual towards behaving in that way would arise and spread. So this is not always true, but it's a general framework for generating testable predictions as to what animals do. Well, what do animals fight for? They fight for territories, they fight for food, nesting material, good locations. Fights often depend on the kind of animal and the breeding systems. If females are providing parental care and males are not, males are going to be fighting over those females. They'll fight other males for territories. A lot of fighting in a lot of animals you think of is among males, but females will also fight for territories, nesting material. They may fight off invading males. They may attack their own young, and young can fight among themselves. There's lots of kinds and ways of fighting out there. Now what I'd like to do is go through some rules for both who wins fights and what kinds of conventions can cause display to end without fighting. I hate to mention size because I'm so short. But it's probably the biggest predictor of victory in an escalated battle, so it makes sense to back down before a larger opponent. It's something we can measure if we look at display. And then the more closely matched individuals are for size, the harder it is going to be to resolve and the greater the likelihood of an escalated conflict. So often in displays, they will be showing their weapons. So when you see battles like this between these ibex, what you've got is two individuals who for some reason have decided they're close enough matched in size that they're just going to have to fight it out, which on the cliffs where these guys are fighting, it's really surprising that they would do this. Or here in these moose. Here what we have is, again, males defending a harem of females. One of these two males was radio collared. It's his 4th year with a group of females. He's had a lot of reproductive success. He's close to the edge of, he's unlikely to live for another year. So this means he is not going to lose anything in terms if he escalates. Well, yeah, he may die sooner, but if he's not going to pass on any more genes, that's how we're thinking, and that's what will evolve. So this is an escalated conflict, and what actually happened in the result of this is the territory owner did die from his wounds from this battle. The loser had very severely broken antlers, which moose regrow every year anyway, so the younger one ended up with the harem. So sometimes it's not overall size, but the size of some specific feature, as in that fiddler crab or in these mud crabs, they want you to know about their specific feature. And they also want to let the other males know. Here they're fighting for ownership of a burrow. Stock-eyed flies, these are a great organism. They're found in the rainforests in Malaysia, and they compete over the distance between their eyes, and females like those bug-eyed guys. The farther apart they are, the more they like them. So what they actually fight with are those femurs, but femurs are the front legs of a bug. So here they are, sizing each other up. And they're not actually fighting. If they actually fight, they'll stand up and go after each other. Here they're two very evenly matched individuals, and they're sizing each other up. And again, these battles will last longer. They're more evenly matched. Ownership. This is caused in the generally very liberal evolutionary biology community a lot of angst that ownership should ever decide contests. But in fact, ownership is often a very good predictor of who will keep a territory. This is some of the first work on this was done with these funnel web spiders, and they fight over the webs, and ownership can work. Speckled wood butterflies, believe it or not, they fight over sunspecks in the forest. Obviously, this is an ephemeral resource. It heats them up, and it's where the females go looking for their guys. So it's, the club is on a different leaf every 20 minutes, but they want to be in the middle of it, and they fight over it. And the owners tend to win, and, scientists, you'd be surprised what you can do without having to get permission with insects. But anyway, you can snatch one away, let another one move in for 20 minutes, let them both go. Well, not 20 minutes because the speck wouldn't last. But anyway, you can make them both think they're owners, and then you'll get escalation. This is a strawberry poison dart frog. Again, these two are very evenly matched. Usually the owner is able to simply scare away the other individual, but otherwise they'll fight. It looks like they're mating, not fighting, but if you're a frog, you only have so many ways of grabbing onto another individual. This is a copperhead. How many of you have seen copperheads around here? I think it's the first poisonous snake I saw when I moved down here. I was very impressed. They're just beautiful snakes. And they mate in the fall, and they fight for females. Males fight for females. And if you, again, the more closely matched they are in size, the more likely they are to escalate. So if you take two males that are 10% different in size, which is very close, and the fight escalates, and then you keep pairing one guy up so he keeps losing, after 2 or 3 times of losing, you pair him with a male that's 10% smaller than he is, and he'll just back off. He's lost heart. And so actually prior experience can be quite a big predictor. This is a rattlesnake, just to show you what some of these fights look like. It probably won't surprise you that these venomous snakes don't actually use their venom on each other to settle these contests. One bites the other would quickly bite it. So see, they kind of stretch up, they see how big each one is, and then they try to whomp each other to the ground. So next time you see a snake, just try to get another one and set up a nice little fight. This is a very interesting other way of reducing conflict, and it's known as the dear enemy phenomenon, or the familiarity. If there's two males, like here we have red-winged blackbirds, and they've set up territories next to each other, a border with a familiar enemy or neighbor, one hopes your neighbors aren't your enemies, but anyway, is simply gets less display. They don't worry that much about it. They know that male. They know what he's going to do, what he's not going to do, and they just go along that boundary. You can then remove the familiar male, put in a new male, and the first male will come and start being much more aggressive. You can also, nice thing about birds is they sing, so you can make songs of the neighbor and then tape record them and then play them as if they're breaking the compact and intruding, and then they get punished for days afterwards. Of course, the other male has no clue that this tape recorder has made him look like a cheater. And this may be the best way of all of avoiding conflict, and that's simply by not competing, but just going straight for the resource. So what you have here is the frog on top is singing, and he's up high, so his sound carries farther. And those two other frogs in the water are other males. So the female comes swimming along thinking, oh, I like that sound, I'm going to mate with that guy. And then the other guy jumps out and says, oh, you like my song? Let's do it. So this is sneaking, and it's just simply completely avoiding the conflict and going straight for the resource. And that's what these roughs do. Here, there's two fighting there. They're the dark form. This is the female who's looking on. And this pale one doesn't fight. He's not territorial. He just goes over and takes the female. And, of course, then the dark guy sees that, but it's too late. He's already mated with the female, and then he goes off. So this is a form of sneaking. These two are fighting away, and it doesn't matter. This can also happen in primates. This is a dominant male in a rhesus monkey troop. This is a female who's sneaked off with a newcomer to the group, not even allowed in the main group, but she's happy to sneak off with them. You can see they're kind of anxious. Anyway, I can't imagine what they're about to do that would make them so anxious, but there they go. Is he coming? Let me know if you see him. Oh, he is coming. Oh, hi. So apparently in these rhesus monkeys, if the dominant male catches them copulating, he punishes the female, not the intruding male. So anyway, make of that what you will. Okay, so in some ways, what I've shown you so far, some fairly simple systems, they all have ways of avoiding violence that have evolved. It's fairly clear that we can look at what's going on and what happens from the perspective of the individual. There's a resource, they both want it, they have ways of trying to get at it, they have ways of deciding, usually through display, before they actually escalate. When they do escalate, we understand fairly well why. Animals that live in groups are a lot harder, because you're not going to just run into that guy once and then beat him, mate with the female, and go about your life. You're going to run into him over and over again. Groups are very different from solitary living. They're a lot more complex. The options, many of the options we've already talked about still apply, but it's not nearly so simple. So group living adds a few options. Here, I'll just tell you, I've got one of my very favorite wasps up in the upper right. This is from Venezuela. These are wasps that actually make a mud nest, and when you bother them, the nest is so strong, they all run inside, and you can just do what you want. Or elephant seals, and of course lions. So one of the things group animals will do to avoid constant fighting is have a dominance hierarchy. Dominance hierarchies can be based on a lot of different things. Another thing about group living animals is often there's relatives in the groups, and how you interact with a relative can be very different from how you interact with a non-relative, because remember, we're evolutionary biologists thinking about passing on genes. You can pass on genes by helping rear individuals other than direct progeny. This is Polistes carolina. These are beautiful wasps. They nest in dark cavities down here. They're common. You'll see them cruising the playing fields, hunting for caterpillars. They'll nest in clotheslines, in attics, in sheds. They are extremely aggressive. And this is a videotape from a study that we did almost a decade ago. And they have a hierarchy that's set up as by who arrives first to start the new nest. These females have all mated the previous year. Any one of them could be queen, but they need a big group to defend that resource of a hollow tree. This is a nest box, but usually it's a hollow tree from invaders. So they have a clear linear dominance hierarchy. And here, when this one is chewing on the other one, you can see the victim kind of hunches down, remains still. The dominant one works her over a little. It's not really escalated fighting, which they can do. It's just sort of, yeah, it's dominance. It doesn't actually show as behavior very often once the hierarchy's set, but that's one example. Here's another. Wolf packs are similar to wasps in some ways, in that there's a single breeding pair, a strict hierarchy. The others help the dominance ones, and you can see there's an awful lot of displaying, from showing the canines to grabbing the head and throat to open mouth displaying. But this is not escalated fighting. Another thing you can have in groups are alliances of various sorts. These alliances can be of the entire group against other groups. There can be alliances within groups, just some individuals. And this is often related to dominance and can determine exactly how things work. In baboons, there are matriarchal lines, and a daughter will assume her place in a dominance hierarchy right under her mother. So you won't have just an age-based hierarchy. You can have very small females that are daughters of high-ranking mothers be dominant to their mother's generation or their grandmother's generation. Lions have both males and females have alliances. Males, as brothers, will often take over a pride, which is made of related females who cooperate a lot in rearing their young. And then the social insects alliances are, there are not alliances within the colony that split them up, but of one to another. And this is just a little clip of gorillas. These are two females fighting, a very upset male in the background. You can fight with someone who's in your same group, but what are you going to do? At the end of the day, you're still right there. What do you do? What do you do? You can have alliances. Others are not going to let you keep fighting. Violence is much less likely to be escalated in groups where other individuals are around, are going to stop things, try to prevent what's going on. Okay, so I've talked about quite a few examples that in some ways are easy and they're clear, and I, at least at the level I've given them to you, I hope they sort of made sense. What I'd like to talk about now is a much more complicated example in a little bit of detail. Elephants have really complex and sophisticated social interactions. The elephant societies are matriarchies, and they can have many different generations together, and the males then are separated from the females, and they fight for females, to mate with females. They don't engage in a lot of parental care. They have this lower than audible to us communication. They can hear each other miles and miles away. And I can remember actually puzzling about must as a student, and I at some point decided, oh, it just means a sexually mature male. They're kind of crazy. But it's really more than that. Males only go into must that are over about 25 years of age, and the younger males, that say 25 to 35, will go into this sexually aggravated state only when there are few females that are actually likely to be receptive. Well, what is this state that they go into? First of all, their levels of testosterone go up by about 50-fold. 50-fold. I mean, can you imagine? I mean, they would be so disqualified from any elephant Olympics. They have a temporal gland which drips nasty stuff that when they're young and not very powerful smells good, but when they get older, it smells really bad. The females really love it. Elephants can be viewed as animals that eat on their way from waterhole to waterhole. They're very water limited. So any sort of display involving water would be very expensive. These guys dribble urine constantly. This means they're not just marking out a boundary, but you can figure out exactly where they've been. They do this for months. Green slime grows on their penis. They dribble so much urine. So these males in must are really spectacular. What does this say about dominance, about fighting? Well, first of all, any male in must ranks over any other male. It can be a small, tiny little male, half the size, and he will rank over a male not in must. Although larger males in must can knock lower males out. So it's definitely a signal of high motivation to escalate. Of course, any male can mate actually, technically, whether they're in must or not, but they just can't get access to the females. The older males can be in this state for 4 or 5 months a year. It's exhausting. They lose weight. They look terrible by the end of it. Why has this evolved? Females love these guys. I mean, these are the ones that father babies. It could be, you could look at the counterpoint and say that these guys have these big tusks. When they fight, it's really something. They can kill each other really easily. And when they're not in must, even if they're a really huge male, they're not going to be in competition. So it could be a way of taking them out of competition and letting them live longer. I don't know. It's complicated. It could be it's just completely from female choice. Let me just tell you a story of how strong this must can be. There's so much poaching of ivory that losing big males is a serious problem for the social systems of elephants. In South Africa, they brought a group of about 10 orphaned males to a site and left them there, and there were no older males. And these young guys went into must at 18 and stayed in it for half the year. They're not supposed to do that at all at this age. And they went nuts, and they killed 40 white rhinos. I know I wasn't going to talk about other species, but anyway, this is just completely pathological behavior. People didn't know what to do. And the elephant people said, oh, just bring in some older males. They shipped down 6 older males. The older males took one look at these elephant teenagers. Those guys went right out of must, and no more rhinos were killed. So it's a really strong and puzzling thing. All right, so I've gone through quite a few battle-reducing conventions. Size of feature, ownership, prior wins or losses, familiarity, sneaking, and then for the social things, dominance hierarchies and alliances. And I was feeling kind of good about this. Oh, yeah, this violent stuff, we can just beat it. We know when escalation happens, similar size, numbers of wins or losses, if both think they're owners, if a neighbor intrudes on a territory, a sneaker gets caught, etc. Basically, there's rules, and if you break them or you can't really tell what's going on, then you will have escalated violence. But the normal state of affairs would be that you wouldn't. You may have high motivation to escalate if there are few alternative resources and a short remaining lifetime, so that you don't really have something to hold back. But usually, for organisms that do have more of a lifetime, there may be other resources. You may be able to avoid a competitor. You don't want to get injured. So you'll make a reasoned guess as to whether you'll win and back off if you won't. But unmitigated violence that leads to death is also a common part of the animal world. This here is a dead bear. It's the only dead animal picture I could find that I liked on Google. It's not what I'm going to talk about. Let's talk about chimps. These guys are in our same genus by any reasonable account. And they have a sort of loose social system where there's groups of males that are together, and there's other groups of males, and there's territoriality. And things can get tight. And sometimes one group will decide to kill off a neighboring group. This is the males. Then they take possession of the females. And you can really call this intergroup warfare. But they don't do it the way you might think, where they kind of start all fighting together. What happens is the stronger group, and it doesn't have to be a lot stronger, it has to be stronger, will just start hanging out at the borders and looking for any time one of the males from the other group is alone, and then they'll go in and they'll kill him. And there's nothing he can do to really avoid that. And I thought I'd just read you a little quote, not so little. This is from Jane Goodall, and it's about these sorts of interactions. 5 adult males traveled south. They moved slowly and cautiously, pausing to listen intently. Fabian led on across Bear Tree Ravine. The party climbed into a tree and started staring towards Kahema. Suddenly, the males climbed to the ground, sat for a minute, then Fabian gave pant hoots, displayed, and raced forward 25 meters to where Goliath, possibly hiding, sat in a tangle of low bushes. Fabian started to attack, leaping at the old male and pushing him to the ground. The attack lasted for about 20 minutes, hitting and biting. Goliath initially tried to protect his head with his arms, but he soon gave up and lay quite still. He had one severe wound on his back, another behind his ear that was bleeding copiously, and another on his head. When the aggressors had gone, he tried several times to sit up, but fell back, shivering all over. We never saw him again. Anyway, after another 2 years, there were no males left in that group, and the females were taken over. When the females are taken over, they also kill the old females who are no longer fertile. So this is our closest relative. Okay, here's another highly social organism. E.O. Wilson might say more social. I might too, I don't know. We probably have more fun though. This is a honeypot ant. These live in the deserts of Arizona, and basically with an ant you can do anything. You have different castes. These are the honeypots, and they just get kind of hung up in the nest, and the others suck on their butts to get out the honey, and that's how it works. And when they fight, you can imagine these things are quite a resource. The land around the nest is also quite a resource. So they have very fancy fighting. They don't want to waste a lot of time fighting, and they have very elaborate displays. And this is from Holdubler and Wilson. Workers rely heavily on surveillance, propaganda, and what can be termed without exaggeration a rudimentary form of foreign policy. They probe enemy territory, set up pickets, and try to bluff their foes into submission with elaborate displays that threaten but only rarely proceed into actual combat. So they have these tournaments along the boundaries. The tournament is a display in which workers attempt to intimidate and chase away rivals. They run back and forth across the disputed field with legs stretched up stilt-like, lifting heads and abdomens and inflating their abdomens slightly. They even climb up on bits of soil and pebbles to make themselves appear larger. If they meet an opponent, they do a kind of dance around each other, kicking and drumming with antennae. And this is a display. They could spray formic acid on each other or slash with mandibles and kill. And they're always assessing how numerous their opponent is. And Bert Holdubler decided that they use 3 different ways of assessing this. First, they'll sort of count the heads visible at one time and retreat if the enemy is more numerous. Or another way is to simply count the soldiers. These are the larger ones that are more defensive. And if there's more large ones, then it's likely to be that they're supporting a really big colony, so you retreat. Then you can also look and see if there's lots of opponents not paired up in a one-to-one display contest. And if there's lots of others, retreat. Very small colonies, just count the soldiers and then retreat. And if there's a huge difference between the colonies, what they do is what these ants are doing here. See, here's the tournaments, the display, and they're kind of checking. These two were relatives. Oh, we're on the same team. Go on. And then they go in, they kill the queen, they kill the soldiers, and they steal the brood and bring it over because then those babies will work for them, and they steal the repletes, and they bring their honey stores over to the other nest. So here's an organism that has very complex, evolved ways of assessing without escalation and setting the boundaries between the territories. But if one realizes they have an overwhelming advantage, they take over. All right, well, there's other kinds of relentless escalation out there. This is a ephemeral environment. This is a little pond in the middle of the desert in Arizona, and the spadefoot toads lay their eggs in there. They have to develop really quickly, and they usually do so in an omnivore form. See, that guy has a tiny little mouth and eats algae and stuff and other things. But this is really weird, but the carnivore morph, when they're really little, if they taste flesh, they then develop into a carnivore morph. And there's the carnivore with a much bigger mouth. He'll often eat fairy shrimp and things like that. But if he runs out of fairy shrimp, he'll start eating other tadpoles of his own species. The omnivores have no defense against that. It is relentless murder and cannibalism, perhaps less disturbing than the chimps, just perhaps. Siblicide is very common in birds that have nests. They'll lay more eggs, not all birds, but many will lay more eggs than they can reasonably rear, and then just let the babies work it out. And what they lay them, so there's an interval of time, so the oldest is the biggest, and then the unless there's an unusual excess of food, they'll simply kick out the babies. So here on the right, you can see the oldest one getting food from the parent, whereas the third one down seldom will. This also happens in pelicans. Pelicans usually get down to just one baby in the nest. What you see here is at the 3-chick stage, the 2 oldest ones are kicking the smallest one out of the nest, and it will perish on the ground. One of these will then kick the other one out. So they know exactly what they've done. The parents do not intervene. Lions. This is a common form of infanticide. If male lions take over a troop, they will kill the babies that are already there. This brings the females into estrus, and then the new males can mate with them. Langurs do the same thing. These are vegetarians. They have those big teeth. Males joining a new troop will kill the babies that are there and then mate with the females. Burying beetles. These guys, they're great. They're really cool bugs. They get dead rodents that are lying in the forest, and they make a little nest in them and put their babies in there. This is, again, a very good resource. Here you have 2 males. One male had this resource with his female, and here he's fighting. It's puzzling that she's just up there on the mouse ball watching as her mate gets trounced. And what's surprising about this is that the new male will then kill all of her babies and start over, and since there'll be much less mouse left at that point, they won't have as many babies. So here's the male feasting on the babies, which will all be either eaten or thrown out so the new mouse can be used. So this is another, these grubs have no defense against that male. Coots. This is sad. This is the mother. She has 9 babies, but only rears 3 or 4. And just at a certain point, she just picks on certain ones and kills them. So we've talked about regularly escalated violence. Fights among very unequal groups, as with the chimps. cannibal morphs, nestmates, infanticide. These are evolved strategies for individuals where the elimination of some individuals of the species by others is how it's evolved. There's no sort of, let's make a deal here, I'll go over there. None of that occurs. I'll just remind you of the earlier kinds of fighting mitigations that I talked about. So, how do we put this all together? We could say that in many cases, escalated conflict is the result of a failure to communicate. If the resource, so it's a failure to communicate, not just let's work it out, but yeah, I really am bigger, you'd better leave, or I really am the territory owner, you'd better leave. It's misunderstandings. It's not that anything can be worked out. And if the resource is valuable enough, the alternative scarce enough, all the communication in the world is not going to avoid escalation. And then in the last set of examples I gave you, escalated conflict involving violence and death of some individuals is simply how natural selection has operated. Well, what's this mean for us? I'd say the evolutionary perspective is powerful in predicting and explaining conflict in animals. Clearly, this perspective has some bearing on human conflict. But humans and their societies are very complicated, and their results are very plastic and flexible. Probably the remaining talks in this series will tell us more about human conflict and what motivates it. Is that a cop-out? But I think it'll always be useful and important to remind ourselves of where we've come from. Thank you.
Thank you very much, Joan. That was a wonderful colloquium. As I mentioned at the outset, we'll have about 10 or 15 minutes for questions. If you could start raising your hands, and if I could get a volunteer from over this side to work the other microphone. We ask that you ask your questions loudly and, thanks, Bill, loudly and clearly enough so that they don't have to be repeated. If any of you don't want to ask a question but simply want to display, I suppose that's all right. But we're really going for substantive questions.
I'm not up for escalated conflict, not yet.
Who'd like to lead off? Okay.
Go ahead, Steve.
Oh, okay. Let me start, Joan. Thank you. Help us think a little bit more about what we can learn about human beings from this. In terms of, we humans live in a world that we construct by language. We decide who our relatives are. We define enemies in ways that are not biologically based. How do you make the connection, and how far do you want to go with it in terms of clarifying the fact that, sure, we all came from there, but don't humans live in a somewhat different kind of world constructed by language rather than by biology alone?
Of course, that's why I didn't go there. There's a lot of things that evolutionary psychology and human sociobiology has figured out. I would say things like how we prefer relatives, how we are tribal, how we have xenophobia, these sorts of things are important for us to understand. But yeah, I don't think biology has the answers. I think it's part of the framework. And, I think that we're very self-interested. Even when we're not self-interested, we want people to know, the T-shirts that say, I gave blood today, those sorts of things. But I am an evolutionary biologist who really likes to test hypotheses and be able to know how far I can go with them. And so I don't work on humans. So I can only speculate, and that's about as much speculating as I want to do.
Next question here. Meanwhile, if you can capture the attention of Bill Wilson or me for the next question, we'll just keep all.
Early in your talk, you've shown some bugs which assess each other by the width of their eyes, how far apart their eyes are. I don't see how this shows the strength of the bug. How does it show the eyes?
Okay, so the strength in those bugs is in the legs, and this is actually a very interesting case where female choice can select for things that are not weapons, and then you can have males coming along on top and using that same character. So if it were just up to the males, they'd be looking at their legs, but it's not. It's also the females, and the females are right there. So the guy with the farther apart eyes is going to be the one the females want. So if the guy with the close together eyes, so it's a complex environment, and there's both the guy you're fighting and the females there, and so that's what they think is why that happened, and it is a fairly unusual case where it's not a weapon, but it evolved probably first because of the female preference.
So you say if you were fighting for something else, like food or territory, they wouldn't care about such a criterion. They would assess each other by some other thing they have.
If females aren't involved and female choice isn't there, yes, you're right.
Thank you.
Is this on? Okay. In humans, you often see acts of violence that don't seem to have any logical reason behind it. For example, sometimes one person will kill another just to see what it feels like. Are there any examples of this in the animal world?
Yes. There's a very disturbing video which I decided not to show. Trials of Life is really a wonderful series. So they have a thing in southern fur seals where a pup gets separated from his mother and goes off and ends up in the frustrated bachelor herd. And the video just shows these males killing the pup and tossing it around and stuff. So the pup's completely helpless. It does them no good whatsoever to kill this pup. And I'm sure there are lots of other examples of that kind, but I would say it's certainly much, much rarer.
Hello, I'm Thomas Wayburn. In your the slide about the ants, you mentioned that you thought they might be counting. That seems unlikely to me, but perhaps the area of their vision that's occluded by the other ants may be registered rather than something like counting, which strikes me as too sophisticated.
So they could be counting. They could be counting encounter rates, frequency of encounter rates. Don't underestimate what insects can do. You can certainly underestimate. You can certainly overestimate our ability to detect what they can do. Yeah, it's hard to believe that they could count up to 15 or something, but some corollary. Yeah, right.
Joan, to continue with the ants, in some respects the ants are an especially interesting group amongst those that you showed because they were the ones that engaged in the closest analogy to warfare, which is group on group. How much do we know about the cues from which they detect the identity of self and other, own group and other group?
So something I did not mention in this whole talk and probably should have is that individual recognition must be pervasive in the animal kingdom. In ants, we know an awful lot about individual recognition. It tends to be based on cuticular hydrocarbons, and each colony has a unique signature. It can also be within colonies, dominance, age, and other things can be signaled, and you can take hydrocarbons from one and paint it on the other and do these sorts of things. So yeah, they definitely know who's who. Is that what you're asking?
Yeah, are these hormonal, like histocompatibility complexes and things, for example, which play a role in higher organisms?
They're not like the histocompatibility. They're both genetically and environmentally acquired. So they're acquired from foods. You can take a colony, split it in half, and leave them apart for a certain amount of time, and then they will fight. They're very, very complex and interesting compounds that actually the Italian collaborators that we've worked with for 20 years are sort of the leaders in having figured that out in Florence.
The genetic environment thing leads very well into my question. I understand there is valid discussion about nature and nurture and human violence and aggressiveness, which I would love to have you comment on if you want to. But I was wondering if you'd at least comment on that aspect of violence in non-human species, to what extent they've determined it's genetic or cultural.
Well, so certainly in insects, I've just given an example of something cultural in that the hydrocarbons will change with feeding. As evolutionary biologists, we're interested in the genetic basis, and there has to be one. But in some ways, what's more important is that whatever is the adaptive behavior be expressed at the right time, and it can have a learning or a genetic component. You would expect it to be more plastic if it needs to be more plastic in the environment, and more fixed or non-plastic if less flexibility is needed. So it's really hard to tease out what's genetic and what's environmental, because even if something's environmental and is advantageous, then over the millions and millions of years that evolution has had to act, any mutation that comes along that facilitates the expression of that behavior appropriately will be favored. So it's a mix, and that's okay. I say this having, now switched my entire research organism so I can actually get at genes for behavior, even though it is an amoeba. But I don't know if that answers your question. Humans? Who knows?
We have time for one or two more.
Well, I was very tempted to ask you to come over and observe my children for a bit. And this actually it relates to the last question and sort of derives from the Siblicide example. But if I recall, almost all of what you do sort of is positive in the sense of sort of violence that seems part of the mechanisms of particular species. And so sort of following up on the last question, I wonder if you observe any examples in which the violence emerges but then is suppressed or punished by those species. So if the siblings, this is my direct problem, but if the siblings are fighting with each other, although a lot of sort of what looks like violence, I understand, would be play, but if there are observations of siblings fighting with each other, you see in the animal kingdom at all the suppression in some way of those violence, or if there are examples of sort of groups excluding from their membership members with violent tendencies.
So yes, certainly. Play behavior and socialization goes on in social mammals, certainly. And you can watch videotapes of interactions where, of monkeys or something, where older individuals are constantly coming over and breaking up fights and suppressing them, and the experimenters can do things like give. We actually have a former undergrad who's at Emory working on primates now. They'll give some juveniles increased levels of testosterone and things, and then see how that changes the group dynamic as the other individuals attempt to suppress aggression in those individuals. So yeah, you'd call that socialization, I guess, and it's very common in highly social mammals. So it's okay. They'll live.
Any others? If not, before we thank Joan, let me simply remind you that we've got handouts here on the front that talk about the program for the rest of the year and also described at the Lang Conference. We will have a reception right outside starting now. I've heard rumors that there's also going to be a brawl, but the Campos have been informed, so you better save it for later in the parking lot. Joan, thank you for a wonderful talk, and let's continue the conversation out on the left. That was really super. That was just great, and all your videos work. They were